Yes.
Okay, solve this. Now don't get frightened by seeing any diagram. I am telling this first thing to you. It is very simple. Just look what is it, write the free body diagrams and just get going. Don't get scared by any words or any diagrams. Right? Understood all of you? Nothing. Just use the right concepts, right techniques. You will automatically get the answer. Okay? Aram se.
Yes. Yes.
Look, angle theta is same. That means it is symmetrically placed. You saw this problem in college?
Yes. No, sir.
Just identify what are all the forces. Not Not, no, I am also in there.
Question.
Now you want to see the question? They told us cylinder, huh? Cylinder. Also got the same answer?
Yes, sir.
You got a different answer? Don't worry. Absolutely don't worry if you got wrong answer. Nobody should bother. Aram se, don't worry. Just see where you have gone wrong. That's all. I also don't know. I have also solved. Okay? I have also solved in front of you. I am also enjoying solving because I also want to learn. Okay? Even though I solve it again, I will learn something from this. So my focus is on that. Somebody got the same answer?
Yes, sir.
You got. Who else got?
So there IP, you wrote it.
Okay, shall I explain this, friends? Hello?
1 minute, yes, sir.
Shall I proceed?
Yes, sir.
Yes, yes.
Yes, sir.
So here, in this diagram, this B is removed, so that the whole thing looks like this. Okay?
Yes.
So my approach, see, if you have got a better approach, you have to just be vocal and just, express yourself. Now, what I identified is, because of this disc, there is a force acting at this point P, and this is giving reaction R. And they are told there is no sliding friction here
Yes, sir.
at this point, and they have made it very clear it will roll. That means now there is no acceleration along this point.
Yes, sir.
So that means this will be equal to this. So there is no acceleration along this. So first get rid of those two forces.
Yes,
And now the only unbalanced force is mg. Okay, the only unbalanced force is mg.
Yes, sir.
So what will this mg do? Mg will do two things. One is it will create a translatory acceleration here.
Yes, sir.
It will create translatory acceleration of this, and at the same time, with respect to point P, it will also create angular acceleration
Angular acceleration.
alpha.
Yes, sir.
Okay. Now, in the question they have asked is what is the angular acceleration they have asked. So therefore, I am not going to think about this. So as far as angular acceleration is concerned, this force mg and the perpendicular distance from this point. Because if this is theta and if this distance is smaller, then we get here the torque will be equal to mg into this distance. What is this distance? R sin theta.
Yes, sir.
Okay, and this must be equal to the product of the moment of inertia about this point into alpha. So that is IP into alpha.
Yes, sir.
Now IP at this point will be equal to IC because they are told it is a cylinder IC plus MR square using the parallel axis theorem.
Yes.
Yes,
Into
sir.
alpha. We get this, and since everything is here, alpha has to be filtered out. Alpha is filtered and written, and this is the answer.
Yes.
Yes.
Sir, I understood everything, sir, but only one thing is friction, sir. Friction force, like, it should act tangentially.
It is acting.
Then you are taking.
But it is static friction. It is static friction. It is only for support. See, every time you are getting confused with this. Assume friction between the corner of platonary and cylinder is sufficient to prevent it from sliding.
Okay, it doesn't slide out.
See,
And then it's
see, you have got it, this one, man. See, now here you see this one, you can see here. See, this is going to go like this. Okay, it is going to go like this. It is not sliding like this.
Yes, sir.
Understand? That's what they are telling. See, this grip is sufficient to hold it.
Yes, sir.
So there is static friction. Static friction will not do work. That's what I discussed in my first class.
Yes, sir.
Static friction is only there to grip.
Yes, sir.
Okay, so therefore that is what they have made it clear. See, supposing it was slipping, then you had to include, if it was slipping, you had to include, because if it is going to slip down, you have to include this vector, friction.
Okay.
If at all it was slipping.
Yes,
Sir,
sir.
even if it is
Wait a minute, then you have to include that vector.
Yes, sir.
Point number one. Now if you are taking moment about this point,
Yes, sir.
yes,
moment about this point, moment due to this force about this point is this.
Yes, sir.
Moment due to all the forces acting here
That's-
will be 0.
yes, sir.
So
Yes,
even though
yes.
it is slipping, it is not going to matter.
Yes, yes.
Understand? It's not good. But gentlemen there, all of you, say here if it is slipping, as far as alpha is concerned here, okay, you have to be a bit careful about that. Okay, because now you will have to also consider summation Fi here. Remember, you have also got to consider summation Fi, because then you see this force and this force, because now we have only considered this as the unbalanced force. Understand? So if this friction is there, then this will not be the only unbalanced force. This will come into picture. Things will be slightly different. But anyway, now let's not complicate it. Let's go with this.
Yes.
Yes, sir.
Okay? What is their
Yes.
solution? Everything is same. Only thing is they are not shown these two forces here. I have shown these two forces here. Got it? Because they will get cancelled, they have not shown those forces.
Yes, sir.
Enjoy, friends?
Yes.
Enjoyment. It looks, the problem looks, oh, क्या है बा ऐसा करके कुछ, लेकिन कुछ भी नहीं. हाँ, अभी से मैं आप लोगों को एक बताता हूँ, कितना भी भयंकर वो डायग्राम दिख रही थी. Don't worry. हमको क्या चाहिए? What are the forces acting? Which point it is acting? What are the physical quantities? Just identify that and see how they get related. That's all. Don't get deterred by diagrams and lot of words there and all those things. Understand? So you must now develop a very matured mindset. See how the soldiers are all trained. Okay, so in the real battlefield, the real bombs are coming, and the enemy strength is so huge, humongous and all. But the soldiers are so well trained, they will never be frightened. They will never get deterred by any of the arms and ammunitions, etc. of the enemy. But they are cautious. Humbu Gutkiyala, hey, Hodi, they will not stand like that. Okay? That's not the way. So they are cautious, they are trained to handle it. Like that only you should develop the mindset. Okay? Fine. Now it's a similar problem, but not exactly same. A thread is wrapped around a uniform disc of radius r, mass m. One end of the thread is attached to a fixed support in the ceiling. The disc is held stationary in the vertical plane. Okay? Plane below support the figure. When the disc is, the moment I remove my hand, when the disc is set free, it rolls down due to gravity. Find the acceleration of the center of the disc and the tension in the thread. Arams. Now do this. Along. Please. Don't tell me, show the figures. Tension and acceleration of the center of the disc. Nice smile.
Yes.
This clearly we can identify this. First equation.
Yes, sir.
Now taking torque at point P. Okay. So again you write here IP into alpha will be equal to mg into R.
Yes.
Correct?
Yes, sir.
And here A, if you are taking IP, then A itself will be what? A will be alpha.
Sir, how do we write A is for mg minus T by R here?
Oh, see, that's what. Now there are two things. One is the net force. What is the net force acting on the mg minus tension? See, it is just a body, man. See, now split. Wait. Split that thing into two. One is translatory motion. See, it is translatory acceleration and also rotational. What causes the translatory acceleration? Net force divided by the net translatory inertia.
Yes, sir.
What is the net force? Mg minus T. And what is the translatory inertia? M. That is one part. It was wrong there. You are right. So IC into alpha will be equal to tension T into R.
Yes, sir.
Yes.
That's perfectly correct. Yes, and from this equation you will have to pull the tension out here from this. So you will get T here from this equation, okay? And you have to substitute that there. Substitute that there. Then you will get A is equal to what you got? Hello?
2G by 3, sir.
2G
By
by 3.
Yes.
And alpha you got what?
alpha, we are not asked.
Divided by R.
Divided by 2G by 3.
Yes, sir. Yeah.
They also asked both. 2g by r. So these are the values. Correct. Quite simple. So you separate out the translator acceleration and this were two equations. One set of equation for summation fi, another set of equation for summation tau.
Yes.
Everybody is silent there.
Yes, sir. Got it. Got it.
All of you got this? Huh? Right.
Yes. There are tensions.
They have asked
Yes.
tension. Yes, what is the tension?
mg by 3 by 3.
mg by 3.
Yes, sir.
Okay, mg by 3. You will get it from this. Okay, friends?
Yes, sir. Yes, sir.
Yes, sir.
Tmg by 3, AC is equal to 2 by 3g. Okay, fine. Everything we got it. Right? Shall we proceed?
Yes, sir.
Yes, sir.
The rod is pivoted at one edge about a point O, the other rod is suspended from the ceiling, the rope is cut. If the rope is suddenly cut, find the angular acceleration of the rod. Remember, it is pivoted here, right? I suppose all of you know what is a pivoted. See, it is like this. Something is holding it. So that if this end is cut, it will simply fall like this. Now this one, everybody, you must only solve with this. Now this is a rod which is pivoted at one end. Gap the length. They are not given. They used it. Take it here. Very confident.
Yes, sir.
No, Dhimat, I must say. Dhimat, you be confident, don't worry. See, you please, I'm telling all of you, don't at all worry if you don't get the answer. Please, please, please don't worry. Leave that school sentiments. In school, if you didn't get answer, you felt totally dejected, humiliated. I mean, everything you felt very bad because you always wanted to be on top. And in school, everything used to be, ready-made questions, ready-made answers. Here, you are learning something which usually the students will learn in their second year engineering. And that too, this subject, strength of materials, is a most dreaded subject in engineering subject. Understand? So even the greatest of the greatest stumble. So if you are all able to do it at this stage, you are wonderful. And you will do better. It's only the beginning. So feel happy. Did you get it right?
Yes.
Are you confident?
Yes, sir.
Good. What about you?
Yes.
Arun is looking more confident than Dhimat. So now, sometimes Dhimat is looking more confident. Sometimes Arun, that is going on in this class. I'm very happy. Okay. Dhimat, be happy, be brave and explain. What did you do?
Sir, like
Louder.
when that thread is cut, sir,
Hmm.
then the one before starting there is mg.
Good.
So now it lacked.
See, here it is very important. Where will you place that
Sir,
vector?
the MG will be acting at the center of the round.
Good.
So, like the distance from that pivoted point is mg L by 2, where the mg force is acting.
Right.
So, when we consider the torque equation about that point to hold that pivoted, then other forces, like all other forces, become zero, and only mg is acting. No, sir.
Only mg is unbalanced force.
Yes, only mg is unbalanced force. So, mg into L by 2 is equal to the moment of inertia about point 2 into alpha. So, from there we will get the angular acceleration of the rod.
See, you have missed out one point. See, there is a force acting here other than mg.
Yes.
Where is that the pivot force?
Pivoted
So
force.
that, see,
Yes,
here there is a reaction.
Yes, reaction force.
But it is, if you are taking moment about that point, that reaction force will not be taken into consideration.
Yes.
So the unbalanced force that you have here is mg.
Yes.
So it is very simple. Orally also you can work out this problem.
Yes.
Right? So the torque is mg L by 2
Ah, sir.
and that must be equal to alpha into what is the moment of inertia of the rod about this point? ml by 3. ml square by 3. So equate it. So one else will go and this, and then you will get alpha. Isn't it? Quite simple. No, it looks humongous. So tuck it, cut it. It's very simple. Correct? So you will start gaining confidence. It's as simple as working with the kinematic equations and all those things, that we enjoy. Yes, well said. Did everybody else get there? The answer?
Yes.
Yes, sir.
Yes.
Yes, sir. Yes.
Don't worry. Things will start looking very simple as days goes by. And trust me, students, if you master these things and collision, okay, then those first few chapters will simply look very, very simple to all of you. Work, power, energy, Newton's laws of motion, kinetics equation, because you are going to use all of them here. Okay, the whole lot of all those 5-6 chapters, is inclusive here. Right? And you will get tremendous confidence. So you got the same answer?
Yes, sir. Yes.
I took the moment of inertia.
What did you do?
Yes, sir. Like I considered first about the center of mass, sir. Then I tried to use parallel axis there.
You took the moment of inertia about center of this one.
ml square by 3.
ml square by 12 you should take.
Yes, sir.
So if you are doing it about this point, ml square by 12.
12 I should have taken.
So if you take ml square by 12,
Then
okay, plus m L square by 2. 4. ml square by 4. So again you will get the same thing.
Yes.
Okay, fine. Don't worry. Initial stages, but be truthful to yourself. See, you have made a mistake, you accept this is my mistake. Oh, your friend didn't make a mistake, so I am not good. All that things are. You are all in learning mode. In learning mode, you will commit mistakes, but cautiously. Do it cautiously. In spite of that, if you have committed a mistake, you will still learn from that. You will correct it. But you should not bring any emotion and commotion into picture. Understand? Your ekagrate, your concentration must only be on learning and not on anything else other than learning. Your mind should be free from all sorts of tensions. Oh, I am weak, I don't know, I should have done better, he knows it better, so it is becoming very tough. All that nonsense you should not have. You should be like soldiers. Understand? So I keep telling Mahatma Gandhi in your heart, right? Einstein in your head, and nerves of soldiers. So Mahatma Gandhi in your heart means yes, peace, truthfulness, being peaceful, but being adamant. You should stand by truth at any cost.
Yes.
Okay. Einstein means, well, you will use a lot of science and scientific temperament. Right? And nerves of a soldier. Nerves of a soldier means, come what may, I will not lose my patience. I will not lose my concentration. I will fight to the finish. But fight to the finish means you will fight to win till the finish without caring for anything. That is what is important. So develop this temperament. See, that is why last year students, they gifted me with 3 books. Okay, one is Wars of India, and then Mahatma Gandhi's book and Einstein's book. They presented 3 books last year students.